Okay. Well, hello, strangers. I am mostly better, except as you can hear, I still have not so great cough, but I think I can talk today, mostly. So I'm going to start off. We're going to talk about VR today as well, but I'm going to start off by going through the slides and talking about the final exam. So I will put the final exam up by Thursday morning before class. I'll probably have it up tomorrow night. So you can certainly take it during class time on Thursday. I will be online in case you have questions. So I'll open up the Zoom channel in case you have questions and you want to join and take it during class. You can certainly do that. Otherwise, I just need it by midnight on Sunday. So you can take it sometime between Thursday morning and end of the day on Sunday. So let me go into the notes here. So the exam will be 10 questions. It'll be all short answer, no multiple choice, no true false, nothing like that. So it'll be 10 questions, all short answer. I'm going to design it to take about an hour. And I'm going to kind of flip through the slides here and tell you the things that I think are more important. I would think that a theme of the exam will be the things from homework assignments. But also I'll point out some stuff that we talked about during class that I would think are extra important. One thing I'll mention is that all my exams have at least one conversion question on them. So you should be able to convert from like binary to octal or binary to hexadecimal or decimal to hexadecimal, something like that. There'll be at least one question that requires you to convert between one number base and another. So make sure you know how to do those things. Okay. So, I mean, as we go through the slides here, everything is going to be important, but I'm going to point out highlights or things that might turn into questions on this exam. So let's see. Certainly mobile multitasking, something along those lines is going to find its way on the exam in one form or another. So that idea of having to, what trade-offs do we need to make for multitasking on a mobile device when we're considering battery life and things like that. So something along those lines will find its way on there somehow. Things about the processor, multi-core stuff, efficiency cores versus performance cores. I'm not going to ask, anything specific. We spent that one day going through looking at kind of the history of Apple processors and stuff like that, where I'm not asking specifics about any processors. This is more going to be the generalistic idea of around processors. Some of it might be, I might give you some assembly code and ask you, what does this code do? I suppose I could ask you to write something very small in assembly, but I think that's unlikely because we only had a short time period to look at assembly with only an 8-week course. But I certainly could give you some assembly. But asking questions about like hardware registers, things like that, things related to the CPU would certainly be fair game. The the idea of having multiple cores. What does multiple cores let you do? What's the purpose of having performance versus efficiency cores? I won't ask anything about neural edges. Go ahead. Oh, no, not a question. I won't ask anything about that. Let's see. Yeah, so here's all our bit bytes thing. Also be prepared to convert between sizes. So like, you know, if I say, you know, here's a 3.2 terabytes is how many gigabytes or something like that, you should be able to work with this chart in one form or another. And I should mention, you know, the exam is designed to be, you know, closed book. Closed neighbor, don't work on it in groups. I want to see what you actually learned. Closed internet, you can use a calculator, but that's about it. So whatever's in your brain plus a calculator is what you should be using to take the exam. You know, it's on Blackboard, so Blackboard has their, you know, anti-cheat stuff for their exam. So I get like a report for each exam. I don't know, I'm sure there's ways around it, you know what I mean, but you know, in any case, just don't do that. Use your own brain and you can use a calculator. Let's see. So something along the lines of our flash-based storage, probably dealing with solid state hard drives versus mechanical hard drives. You know, nothing about specifics. Like I won't ask you things about, you know, specific, you know, what's the speed of a solid state drive or something, but it'll be, you know, some question asking you to kind of prove that you understand the reasons why a solid state drive might be faster than a mechanical hard drive. You know, that kind of stuff will probably find its way on there in a question. This idea of computer architecture versus operating system. So, I mean, I probably wouldn't ask you specifically a question straight off of this slide about, you know, why is a compiler needed for that? But there'll probably be a question about that relationship between the operating system and the computer architecture in terms of system calls and that kind of stuff. So that'll be another question on the exam. That's what all these are about. Something with Bitwise Operations will probably be on there, where I'll have you, it could be where I give you a hardware register with maybe a couple of values stored in it and ask you to tell me the steps necessary to extract a certain value using Bitwise operators, something like that, something similar to what we did in class. That's kind of what that group of slides is for. Nothing about that. Okay, yeah, so this is what I was mentioning. If I were going to do something with ARM architecture, I would probably give you some code and ask you, what is this code accomplishing? You know, would be something with like, 5 to 7 lines or something like that, not like a bunch of code. So when it comes to iOS versus Android, I could see asking some question, maybe even along the lines of the multitasking stuff. Um, you know, maybe asking you to explain why maybe multitasking was left off of early iOS devices, or why did Android choose to do it, something like that, kind of showing that you understand the thought processes going into those two different operating systems at that time period. That would be maybe wrapped into a question about multitasking, and that it takes extra battery life, extra CPU power, and the things we did with the devices were different, and that kind of stuff. So it'd be less of a right and wrong answer and more of a, show me that you understand kind of some of the things involved in that discussion. Certainly that idea of binary versus octal versus decimal versus hexadecimal, and why those are actively used in computers today, specifically the octal, binary, and hex, and the fact how you can move between those very easily, and the amount of storage each of the values actually takes. So that's kind of what that homework assignment was about. Nothing with that. And like I said, I'm not going to ask you anything specific about like this slide where, I'm asking you, what are the available hardware registers or something. I would ask you to look at some code that does something. So I suppose you should be able to, recognize a register, like if I say R0, R4 or something like that, I'm talking about a register. But read some code and tell me roughly what's happening. Some data is moving between here and there, going to memory, coming out of memory, whatever it is. Something along the lines of like this. Gave you this code and asked you to tell me what is this code accomplishing. You should be able to do that. And I probably would not be giving you the the comments out here to the right. But when I'm asking you what code is accomplishing, I'm not asking you to tell me what each individual line is doing. I want to know, what is this code as a whole? What problem is this code as a whole solving? Okay, so for this particular case, this code is determining the maximum value between R0 and R1. That's what it's actually accomplishing. You should be able to pick off some of the things that we have in here, but we didn't do tons with it. So I mean, you should know about like moves, and if I say add or subtract or the compare, really the things that are involved in this. I'm not going to throw any like random assembly instruction that we never really talked about even at the high level. The ideas of loads and stores, moving from memory into a register versus moving from a register back into memory. So kind of code that looks like this. Yeah, this is the stuff about what if you want to use your amount of bit space, 16 bits, 32 bits, whatever it is, to store, larger amounts of information, maybe 2 values or 4 values, something like that. How does that actually all work? So that would be fair game. And I would probably maybe give you the current state of a register and ask you to show me the bitwise operations necessary to extract the first value and the second value, something like that. Okay, so that kind of gets us to where we're talking about today. There'll probably be at least one question, probably exactly one question dealing with the stuff we're going to talk about today, and I'll kind of point out the things that are seemingly important. Again, the focus will be kind of what was on the homework assignments, like the inside out tracking versus outside in tracking, that kind of stuff. So we'll get to that stuff today. So outside of that, any questions about the exam?
You say general notice for the assembly code would be to look back at stuff like you showed on that one website and stuff that you showed in the slides?
Yeah, but I would say definitely put an emphasis on looking at assembly code and telling me what it does, not writing it yourself.
Right. Okay. Yeah, actually explain it, like not go line by line, but actually, like you said, with the one.
Tell me what these 10 lines together accomplish.
That makes sense. Okay.
All right. Anything else on the exam?
Is there a specific date you're expecting us to complete the exam?
Yeah, I said by midnight on Sunday.
Thank you.
So it'll be up before class on Thursday. I will get on to Zoom here. So if you wanted to take the exam during the normal class time on Thursday this week, you can. And I'll be available on Zoom if you have questions or whatever. I don't anticipate that you'll have questions, but if you do, I'll be active during class. So you certainly can do that. Otherwise, anytime between, just you have to do the exam at a single sitting. I'll probably set the exam to like not really have a time limit or have a very broad time limit. Maybe it'll be like 2 hours or something like that, but the exam is going to be designed to take an hour. But you do need to do it all in one sitting. And like I said, Blackboard, when you take an exam on Blackboard, and it's going to be on Blackboard, it's not like you're going to download a document. You're going to go onto Blackboard. Blackboard's going to have a way of presenting an exam to you, so it has software built into it. It'll know if you go and start jumping onto Google and things like that. So like I said, there's obviously ways you can circumvent some of that, but just don't do that. Use your brain and use a calculator for doing the homework or doing the exam. But it should take about an hour to do. All right, anything else? Okay, so then let's talk about some VR stuff. Let me just make sure I see what you guys did for. Um, okay, so we'll talk about that. And then VR tracking. And then these things we didn't really get to. Okay. So when we talk about virtual reality, I'll bring up a headset here for us to look at. Let me make sure none of these chat questions were, yeah, they weren't. You know, so when we talk about something like VR, we're looking at, like, this is the Oculus Quest 2 VR headset. You know, and you know, what's interesting about this is we're focusing here on mobile VR. So I'll kind of mix and match our the last two homework assignments together into a single discussion. So, you know, this is somebody using the Quest 2. So they have this, we can think of this like they effectively have a smartphone strapped to their face. So, you know, this guy has some special kind of lenses in it that allow you to, they're called Fresnel lenses that allow you, you know, that kind of give you some depth perception and things like that. But, you know, the idea is that it's trying to give you the concept of, you know, being in a virtual reality. So, you know, you are no longer playing a game. So let me kind of show an example here. Yeah, so here's like World of Warcraft. So for example, if you're playing, you know, a game like this is a, you know, a flat screen. This is not in VR. This is a flat screen game called World of Warcraft. This is your character on the screen. So you would, you know, drive them around either with the keyboard or with the mouse, and you'd push, you know, buttons like 1, 2, 3, whatever for his special moves. So, you know, you would run over if you wanted to attack this guy, you'd click on him and then put your guy into fighting mode, and you'd run your guy over to him and, you know, start using your special abilities to, you know, kill somebody. That's your normal video game, you know, traditional video game. And I don't want to think about VR as being all about games, but at the same time, you know, that's kind of where VR started, is with games, because those are the folks that had the hardware that could drive the VR headsets. And hopefully that came up as you were looking at the inside versus outside in tracking, because the outside in tracking is mostly on PCVR, and will, you know, those require significantly more horsepower to drive those. Where if I look at Zenith VR, so this is a similar genre game, so-called Zenith VR. It's on the Quest 2. So instead of your guy being on the middle of the screen, you are your guy. So these are your hands. This is your weapons, or whatever. You know, here's the enemy you're attacking. So, you know, the whole, you are living in the world, and the world, you're seeing the world through your perspective. If you turn your head to the left, you're going to see land and stuff over here to the left. You can turn to the right, so on and so far. You look up. So that has some interesting ramifications. On one hand, you're actually probably seeing less of the battlefield at any point in time, because you're only seeing what's in your peripheral vision and things like that. Whereas on that other game, the World of Warcraft game, you know, you see this kind of broad area, even the stuff that's behind you. You can see somebody else running up behind you, you know, causing problems. And that would be something that, You know, if you're in VR, you'd have to like, oh my gosh, somebody's hitting me from behind. I need to turn around and take care of them. So it does change the way you are interacting with the world. And all this is happening because of location of your eyes relative to the monitor. So when your eyes are, 3 feet from the monitor, like they are in a, normal, video game, normal like playing PlayStation or playing, PCVR or something, or PC video games, something like that. The game has to be presented to you in a certain way, and the way you're controlling the game is usually through a keyboard with a mouse or through a joystick. With VR, we're controlling the game. I'll just go back to the Quest 2 thing here. We're actually controlling through these hand controls. So when you move your hand around holding this control, it's being tracked, and you see your hand move inside of virtual reality. Same thing with your other hand here. When you turn your head from right to left or up and down, things like that, it's being tracked as well. So that's how you're looking around in the world. It's a whole different perspective on how you are interacting in a virtual world, whether it's a game or whether it's going to a sporting event in VR, or Google Earth is pretty cool in VR, where you can fly to any place on the planet and go and kind of walk around the streets. And when I have the international students get into a headset, a lot of times I'll have them fly over to Hyderabad and go a lot of you are from Hyderabad, and go walk around the streets, go to the mall that you're familiar with, and you're there. It's kind of an interesting first thing that kind of separates that idea of a video game from I don't know, a virtual experience. Travel is also a big deal, and in VR you can throw, and really YouTube VR. So if we go to vr.youtube.com, actually, let's just do youtube.com. And I'll do something like 360 VR London. Yeah, so here's the London 360 experience. So the idea is you put a London city guided tour. This is a good one. I've been on this one. Sure. VR Gorilla is they do a lot of high definition tours. So if I click on this guy, imagine if you were,
so come follow me.
Turn the audio off on that. So he's taking me around London, but if I was in a VR headset, I could turn my head, I can look all around. I'm moving my mouse around, I'm faking it here. But if I was in a VR headset, it would be as if I am standing here, following this guy's tour, and I'm looking at all these people, walking around. So I mean, you're and this is, high resolution. This looks good. So that's some really cool, use cases for virtual reality. He takes you to some different places in here. So it's not just all standing there in one place. And you can do this for, hundreds of different, locations. Now we're on a subway car in London. So, you can, you're experiencing it as if you were there. You're not getting the smells or the wind or the whatever, but from a perspective of, hey, if I was standing in the middle of a subway car, what does the life look like for that? So these are really cool applications of virtual reality, that I think are often overlooked because we think of them as gaming systems. And just out of curiosity, I'd be surprised there's not one of Hyderabad. Yeah, here's a 360 tour of Hyderabad. Several things here. Go visit Hyderabad. Here, look all around. So this guy might be taking you on a guided tour. I'm not sure if he's just doing whatever. You know, but this is something you can do with something like a Quest 2 headset. This headset's $300, and you could plop it on without having a computer and go and visit Hyderabad, go visit London, go visit Egypt, anything like that. You can go and watch a cricket match in VR. It might be a little hard to find, but I know they exist. You know, all sorts of sporting events are now starting to show up in virtual reality, where you can, you know, you can watch these things as if you're if you're there. It's really amazing. It's the way that, you know, sports should be watched in my view. So kind of a cool a cool type of thing. So you wrote a paper looking at the Quest 2 versus Quest. Back to this. Hopefully this guy gives you kind of a, so the Quest and the Quest 2, the black one here is the Quest, this one's the Quest 2, you know, and these guys are kind of big deals in terms of where they came from. You know, the Quest 2 is better than the Quest, mostly because it's cheaper. It uses a little bit better hardware and things like this. Processor speed. The controllers are similar, but have been a little bit redesigned. But in any case, you know, these are pretty similar headsets. But if you pretend like these guys are effectively the same headset, which is, this is, you know, revision 2 of it from a hardware perspective, you notice these cameras on the outside of this guy. This is something to support the outside or the inside out tracking. And let me show you the alternative to the inside out tracking. Just go to Valve Index. Valve Index setup. All right, so where did I click? All right, so here is another virtual reality headset. This guy still is sold today. It's more expensive than the Quest 2. This is a Valve Index. It's $1,000. Now, first of all, this is a PC-based VR headset. So you can't use this guy unless you have a computer that it's plugged into. Now, notice there's a cable coming off the back of this. So you are tethered to that computer by that cable. There are some things like I have a VR room at my house where I have some stuff along the ceiling that kind of hold that cable up for cable management so that you don't step on it and things like that. Kind of unimportant for us, but our focus here is more on the tracking. So notice, so this guy is standing here, he's doing his VR stuff. He pretty much has to stay somewhere on this, you know, I don't know, blue-gray matte thing that he has sitting on the floor. Because if you look up here on the room and over here, there's these 2 sensors. Okay, so these are external sensors. These are steam trackers is what they're called. So these guys are, this is outside in tracking. So these sensors are watching what your hand controls are doing. They're watching what your headset is doing. So they're seeing you move around in virtual space and tracking it. So virtual reality like this requires you to have a fixed room setup. You know, you're not going to sit there and install sensors like this on the walls very, you know, very quickly. Yes, it's movable, but not conveniently movable. So kind of Now, even today, people would say that the best quality tracking is outside in tracking. So something like this will track better than the inside out tracking of the Quest 2, but not substantially better. You know, you have, for example, if this guy were to put his arm behind his back here, he would, that arm would still be tracked because these sensors would still see it. If you were using a Quest 2 that's relying on the cameras that are on the headset here to see it, as soon as you move your arm back here, he can no longer see it. Now they have software to kind of fake it. They saw the direction your arm was moving, and you know, they tried to predict where your arm would have been. So it doesn't completely miss it, but it's much less accurate in situations like that. But you imagine that most of the time you're working with your arms out here in front of you, and that headset's able to see everything you're doing. All right, so you know, pros and cons. Outside in tracking is more accurate tracking, but less convenient tracking. Whereas a Quest 2, anywhere you can carry that headset, especially when you consider that the headset does not require a computer. Anywhere you carry that headset, you can immediately start doing VR because it's seeing the room you're standing in. Here were some visuals that show the difference between the Quest and the Quest 2, just for and this is PCVR, so this is actually kind of maybe going to be an interesting. So
Professor Lehman, I have a question in regards to something.
Sure.
Because one of the disadvantages also about inside out VR is that is about latency, and I kind of understood the explanation a bit from what I was researching, but do you have more knowledge on like what, because like from what I got was that the latency issue, the reason why it's such an issue is because of how it causes motion sickness. And so do you have any more?
Yeah, I guess there's two pieces there. So the latency they're talking about is, since you're using these cameras to see where your hands are moving and stuff like that, as you move your hands super fast, you know, how well are those cameras going to be able to keep tracking your hands? You know, at what point is it such a blur? And there is that delay between the camera seeing your hands, or seeing the controllers and processing that image and then doing something with it. Even though from a human being, it's pretty much real time. It's not exactly real time. There is a slight delay. Whereas the outside in tracking doesn't use cameras. It uses infrared and some other, you know, radar type technologies. It's not actually radar, but technologies like that are getting signals back that are already kind of pre-translated. So it can make decisions of where your hands are going much more quickly. From a motion sickness perspective, I mean, I suppose it's possible in situations where maybe like flight simulators or something like that, where real-time motion, like actual real-time motion, is extra important. You know, where when you move, you know, you tweak something a little bit, and the difference between 3 microseconds and 8 microseconds might actually be experienced by your inner ear or something like that. I suppose that is possible. I wouldn't say that is a major concern on a high percentage of VR experiences. I would think it'd have to be very specific. A lot of the simulation stuff, race car simulations, flight simulators, that kind of stuff. But like I said, at the end of the day, if you always do your virtual reality in the same room, and you want the absolute best of the best tracking, outside in tracking is still better. But if you want the convenience of doing your VR wherever you want, so for instance, if you're playing a VR game for 5 hours, okay, maybe going into a set room for doing that makes some sense. But let's say that I just want to plop down on the couch and watch a basketball game in VR. There's a whole lot of freedom that comes with being able to throw the Quest on, and with the inside out tracking, I don't have to worry about what part of the house I'm in or even where I'm located on the planet. All the things I need to do VR are right there with me. I don't need to be near my computer. It's all just, all just set. So maybe at the end of the day, the idea is that, the more hardware performance you're able to bring to the table, the better the end user experience, but the less flexible it ends up being. So something like the Quest or the Quest 2, which is completely all in one, does not require a computer. So it doesn't require external sensors, doesn't require a computer. It's completely wireless. It runs off a battery, just like a smartphone. That buys you a whole lot of freedoms that you don't get with standalone, or you don't get with PC based VR with those external sensors. Now, what is interesting here is, so what they're showing on the screen right now is this is the Rift S versus Quest 2 versus Quest. Now, this is a little bit of an interesting thing because the Rift S, also made by Oculus, they don't sell it anymore, but this is PC only VR. So this connects to a computer, you have a cable that runs to it and stuff like that, but the Rift S had inside out tracking. So you would have been stuck in a room just like that Valve Index picture I showed you, but you wouldn't need those external sensors. You just had to be within physical proximity of your computer for the cable to plug in. So the Rift S used that inside out tracking, and even when it was like that, it still was preferred because the ease of setup was much better. All you had to do to take your Rift S to another place was to unplug it and take it to a different computer that was capable of driving VR. And then you had it set up. You didn't have to take your sensors down or any of these other things. So this was almost a hybrid approach. But something you do get to see in this picture is the, I'm not sure what game this is, might be Arizona Sunshine, maybe. Yeah, Arizona Sunshine. This is the Quest 2, and then the Rift S. And like I said, the Rift S is PC only. The Quest and the Quest 2 are mobile VR. You can use them for PC. So you could actually experience something like this on either of these devices if you did hook it to a computer. But in terms of using them for what they were originally created for, initially you look at the Quest versus the Quest 2. You see that the Quest resolution is a little bit fuzzier. The shadows aren't quite as crisp as portrayed because the processing power is a little bit less. So the Quest 2 visuals are much better than the Quest. But if you look over here at the Rift S, no longer are you actually comparing the same scene looking through the lens. Now you're seeing what are the trade-offs of PC-based VR compared to mobile VR. Because in Quest 2 and Quest, these guys are using mobile RISC processors. They're using a mobile graphics card to handle all the visuals. Whereas this Rift S, this is related to, hey, whatever kind of high-end PC processor you have, high-end PC graphics card you have. So it's not having to make these trade-offs. I mean, just look at the the backdrop, the mountains. This is much more photorealistic over here. This isn't even trying to be. This is it's not about these devices rendering this differently. It's about this is a different image, because these guys, if you tried to do this exact same thing over here, the device would bog down. It wouldn't be able to handle all those shadows, the number of polygons it has to have on the screen at the same time, all those things you see over here on the side. The ground is basically, all, dirt or whatever over here, where, you have this mixture of grass and dirt, much more realistic type thing over here. You have a much more fill-in of images. So this is reliant on PC-based computing resources, where this is showing you the trade-offs you have to make for mobile-based computing resources. Just kind of an interesting thing. I'd still argue that the Quest 2 is the best of all these devices, and really so would Facebook, since they've discontinued the Quest and the Rift S, because you can take this Quest 2 device and you can plug it into a computer and experience this. Because actually the Quest 2's visuals are better than the Rift S's visuals, or at least every bit as good. They use a little bit different technology for it, but the Quest 2 is actually higher resolution than the Rift S. But if the Quest 2 plugs into a computer or wirelessly does VR that's driven by a computer, it's no longer reliant on its internal graphics card or its internal processor for dealing with the graphics and things like that. Now it's fully relying on the computer to do it, and your headset effectively becomes a wireless monitor. So just kind of an interesting comparison when you look at these different devices, but all three of these devices use inside out tracking, which was a little bit weird with the Rift S, but which was incredibly freeing starting with the Quest, where you can do a pretty high majority of your VR experiences. Because any of you who have sat down with me and really talked VR have heard me repeat over and over again that gaming is not the killer app for VR. You know, the killer app for VR might be, for example, like I showed you a few minutes ago, like the tour of London in VR. So maybe travel, where you just throw a headset on and all of a sudden you're transported to another place. Well, that was just a 4 and 8K 360 video that you were watching, and you can do live streams of those too. So it's not even a recorded video. You can be part of a live concert or something. That doesn't require a computer. That's just streaming. That's just streaming video. That's an internet connection that it's reliant on effectively. So that's where having a standalone headset really gives you a pretty high percentage of the killer uses of VR and takes away the cost of having to have a high-powered computer driving a this could be another interesting this actually shows a similar thing. So I mentioned a few minutes ago that you can connect the Quest 2 and the Quest to your computer directly. So now what you're seeing here is you're seeing PCVR graphics on all three of these and what it looks like. And you might notice here, and maybe it's it's kind of close. Clearly the original Quest is a little bit grainier, a little blurrier, stuff like that. But if you look at here between the Rift S and the Quest 2, the Quest 2 is sharper. I mean, you have less, if you kind of look in this area, like right around here, you know, you have a crisper picture over here. You know, it's a higher resolution screen on the Quest 2 than it is on the Rift S. And you're no longer reliant on the Quest 2 driving the shadows of the graphics and stuff like that. So, you know, you're able to bring all that into the computer, and using the Quest 2 as just a monitor. It might even be easier to see when you come down to read text. Notice how much clearer like the number 17 is down here than it is over here on the Rift S. Much easier to read the text. The 55 is clearer. You know, maybe the Rift S and the Quest are similar, although if I had to pick one of those two from a text reading perspective, it might be tough. I might pick the Quest. It'd be close between the Quest and the Rift S, but the Quest 2 is clearly better than either of those at PCVR. So now you have this standalone headset that's $300. It's the cheapest of these three headsets. You can't buy these other ones anymore, but when they first came out, the cost of them is more than the Quest 2 ever was. So it's the cheapest of these, and you can do standalone and PCVR with that single headset. It's pretty impressive. So just kind of something worth worth considering when you're looking at these things. But again, the killer application for VR is, in my view, is not gaming. It is a use of VR, but it's not the only use of VR. And if you're going to say if you only use VR for games, maybe the Quest 2 is not your best bet, unless you're going to use it for PCVR, which a lot of people do. If you go to, let's see, VR headsets percentage. All right, this was February 7th. Okay, so this is using PC. So whenever somebody says Steam VR, they're talking about PC-based VR. Steam is one of the main software, I guess, clearinghouses or whatever on PC for VR applications. So headsets by Facebook, and this is primarily going to be the Quest 2, maybe with some Quests and Rift S's strewn in there, but a very small percentage. This is primarily the $300 Quest 2. So 67% of PCVR is being done with a Quest 2, even though it's designed to be a standalone, not requiring a PC VR headset. Well, that's pretty impressive. This is people who have a computer capable of driving PC VR graphics, who also happen to have a Quest 2, who either wirelessly connect with their Quest 2 or physically plug their Quest 2 into their computer and experience PC-based virtual reality using their Quest 2. And that makes up 2/3 of all headsets doing PC VR right now. HTC Vive is 11%. Valve Index is 14%. Windows Mixed Reality is 5%. I'm surprised it's even that high. And then other would be like Pimax headsets, kind of, and some of these are pretty high-end headsets. I have a Pimax 8K headset that would fit into this category. And, it's a pretty cool headset. Again, it uses outside-in tracking, but it has a 200-degree field of view, so you can see a lot more of the world at once and all this stuff. But, it still is a, less popular type of headset. So just kind of an interesting breakdown when you look at that Quest 2 and you see that this guy is effectively a one-stop shop for all VR. Now, when we look at kind of how we got to this point leading up to the standalone VR, we originally had something called Google Cardboard. Google Cardboard here. The way Google Cardboard would work, and it literally was made of cardboard. So you would get this, this device like this made of cardboard. You would throw your smartphone into it, and then you'd connect. You'd close the lid. You'd put the thing on. This had your Fresnel lenses in there, and your phone would go into Google. You download the Google Cardboard app, and you would be in Google Cardboard mode and doing mobile VR using this effectively this cardboard thing that allowed you to strap your smartphone to your face. That's kind of where it started for mobile VR. Google then came out with their own VR experience, never actually took off. It died off. where they had this this headset that you would get called the Daydream, and you would throw your phone in there, but it was actually running this special operating system called Daydream. And it only worked on it worked on initially only worked on Google Pixel devices, or originally it was HTC devices as well before the Pixel came out. So only certain devices. Later on, it opened up to all Android-based devices. This was a pretty comfortable headset, but notice that it didn't have full hand controls. It just had these this little clicker thing. So the thing is, I would even argue for most of what VR does, that's adequate, because most of what you do in VR is like those travel things and stuff like that, where most of what you have to do is just move your head around. Those hand controls where you're manipulating things and stuff like that. Yeah, yes, that's interesting. Yes, it's necessary for many applications, but for a whole lot of applications, it's really not. If you're sitting there watching a basketball game, you don't really need to have full hand controls. You really just need a TV remote type thing to click on, mute the audio or mute the mic, something like that. Now, at the same time as this, Oculus had a device called the Gear VR. So here's the Oculus Gear. Notice this only worked with specific Samsung phones. This was like something done with Samsung. So your phone would click into this device, and it was running a operating system that is very, very, very similar to what we see in the Quest 2 and the Quest today. This mobile VR operating system. So at the end of the day, it's not just about the hardware, it's also about the software that's delivering the experience. When you go back to the Google Cardboard days, one of the downsides of Google Cardboard was that you didn't really have an operating system for launching your VR games or VR experiences. You really had to start up something, then put it into the Google Cardboard, put it on your face, play it till you were done. And then if you wanted to switch to something else, you would go and switch to a different piece of software, whatever it was. That was a problematic type situation. Whereas with the Gear VR, you plugged your Samsung device into it, and it went into a Oculus based operating system that looks a lot like what we have now, where you could launch your games right from in there. You had YouTube VR, you had Netflix, you had all these things that were right there in VR. One of the things I even tell people is, like, with these VR headsets, you can watch Netflix on 100-foot screen in a broom closet. How many people have entire rooms in their house set aside specifically for like their living room? Like right now, I'm in my kitchen, but I'm looking back at my living room, and I have my 70-inch flat panel TV in here, and my comfortable chairs and stuff like that. Yet I could put my VR headset on that's sitting over here next to one of my chairs, and I can watch Netflix on a much, much, much larger screen than I can on that 70-inch TV inside of VR. It's better. It's a better experience. It's like going to the movies. So I mean, you really gain a whole lot when you deal with the perspective that VR gives you. And the Gear VR was something that gave that to Samsung people early on. In fact, it was, I would say, a really, really great thing, with the exception of heat. If you were doing any sort of game type thing, this overheated pretty quickly, where it would, you'd get a warning on the inside saying, you gotta, we're shutting down right now because your phone's getting too hot. So it wouldn't let you damage your phone, but you maybe only got a half hour of play out of it or something like that. So people started, creating devices. Let's see if we can find any. Yeah, stuff like this. You could 3D print stuff that would wrap around your phone and have a fan in there to try to cool your phone off while you were doing VR. It was kind of a, a fun thing, and that would give you a little bit more time. Time on your headset. Just kind of a, you know, interesting history of these things. From Gear VR, which did require you to have a smartphone. So Gear VR was a device that then had, that you would buy just the device and you would put your own smartphone into it. And it had to be one of the compatible phones, but you would put your own smartphone into it. So your smartphone was still the brains of the device. The device was just kind of like a really high-end Google Cardboard that was also compatible with with the special software for Oculus. So from there, we had something called the Oculus. Am I not coming up with the name of it?
Oh,
Oculus Go. You have the Oculus Go, which looks like this. So notice the Oculus Go looks a lot like the Oculus Quest 2. They're right next to each other here. But the Go does not have any of these cameras on the outside because you're not tracking any hand controllers. It has this single hand controller, very similar to what you had for the Gear VR or for the Google Daydream, you know, just for pointing and clicking. But this was a great device. You could do most of what I would still say is the killer applications in VR you can do with the Oculus Go. You know, you couldn't do these latest, greatest, you know, full hand control, you know, video games, or, you know, one of the most popular games is a game called Beat Saber, where if you've seen this guy, Beat Saber looks like this, where you kind of have, you know, or here looks like this, where you have your two hand controls are holding on to these like lightsaber looking things. And you're hitting these things and it's music is going along, whatever. So this requires two-hand tracking and all that stuff. And also, you know, your headset moving in all sorts of different directions because you're ducking things, you're turning sideways and all this stuff. So it requires all those extra tracking type stuff for very specific applications. But for things like Netflix or YouTube VR, you didn't need anything more than this. The only thing you're really gaining with the Quest 2 over an Oculus Go is visuals. The Quest 2 just has a, you know, better technology for the LCD panel for resolution, and it has you know, clearer lenses, that kind of stuff. So this is all the things that are currently happening. If you go to the Oculus, it's probably called the Meta Cambrian now, but this will get us to the right place, I'm sure. So this is what Facebook's next headset is going to look like. It's not the replacement for the Quest 2, but it's a higher end type of headset. This might be a good one to look at. That has like eye tracking built into it. It has a way of detecting your facial expressions, like if you're smiling or your lips are moving, things like that. So it has a lot of these extra bells and whistles that are part of it, but it's going to come at a higher price point, and the Quest 2 is still going to be around. But from our perspective here, I mean, this device is not even announced officially by Meta yet in terms of its specs. They just said it is a thing, but it looks like it's coming out maybe September, October, something like that. But what's interesting for us right here is this device also uses inside out tracking. But if we zoom in here on the controllers have little cameras on them. So not only is the headset looking for the controllers are looking for the headset. So now when you do that thing, like your hand goes behind your back or something like that, you don't actually lose the tracking because the controllers are tracking themselves. So now you're closing that gap between the inside out tracking and the outside in tracking, some of the pros and cons of it, by adding some technology to the controllers themselves with the Cambria. So kind of an interesting direction that things are getting ready to go. So one of the things you maybe saw in here is the difference between 3 degrees of freedom and 6 degrees of freedom. So the Quest 2 has 6 degrees of freedom. The Go has 3 degrees of freedom. So this has to do with the hand tracking, and also, you know, with the head. Can you move side to side, up and down, but can you move out and in? And this deals with something that historically has been called room tracking. Can you actually physically move around in your space? When you set up your Quest 2, or you set up your Valve Index with outside in tracking, what you effectively do is you draw an area in your room that is available for VR, a place that doesn't have, you know, tables and chairs and things like that that are going to get in your way, you know, your safe space. And while you're playing your game, you can physically move your body anywhere into that area. So you're not just stuck with whatever you can reach. You can actually walk 3 or 4 feet in a certain direction, or more if you have a bigger space. So it allows you to accomplish some pretty neat things. I'm a big advocate of mobile VR, even though I actually primarily use my Quest 2 for PC VR. If I'm going to do a game or something. So if I have the option to buy a game that's on both the native on the Quest or also on the PC, I'll buy the PC version of it because it has the capability of the better graphics and stuff like that. And then I'll play that wirelessly using my Quest 2. So I don't have to leave the room where I usually do my Quest 2, because I just have a wireless network set up in my house specifically for high-speed virtual reality. So I kind of get the best of both worlds, if you will. But a majority of what I would consider the killer applications for VR, you don't need a computer for those. That's like going to a movie in VR, going on a travel type thing. These are all things that you can get the equivalent quality in a mobile headset as you can on a PC, because you're not rendering graphics, you're just playing video. It's a pretty interesting type thing. Now, one cool thing, so, and this is something I use pretty often. So on the Quest, they actually have their own software for doing this now, but on the Quest, they have a something called virtual desktop that allows you to bring content from your computer into your VR in kind of a convenient way. On paper, originally it's like, oh, well, what if I want to play, what if I want to use my computer from within VR? Well, that's only going to be so useful, I think, at the end of the day. But now they've built that software such that you can launch games. Most importantly for me, you can launch virtual reality PC VR games from virtual desktop and have them launch and play inside of your mobile headset. So it allows you to do some pretty cool things. So now your ultimate wireless VR is your Quest 2, which is a $300 headset, which you can actually do PCVR with wirelessly at a higher resolution than almost all of the current affordable and available PCVR headsets. The Quest 2 is at least as good visuals as the Valve Index. It gives up a little bit of a field of view. The Valve Index has a wider field of view than the Quest does. I think it's something like 90 for the Quest versus 120. The Pimax 8K gives you 200 degrees of field of view, which is ridiculous. So, you know, you probably do pick up field of view when you get over to PCVR specific. But something that I think is going to be interesting coming out that I really wonder why they made this decision, for those of you who are like PlayStation folks, you know, the PlayStation has their own VR. They have the PlayStation VR, and it's been out for a long time, and you know, it's still fine, but it's much older technology. Well, they've announced their PlayStation VR 2. Who knows when it's actually going to release? Let's maybe say sometime by the end of this year, but you know, maybe that's wishful thinking. What I find very interesting about it is that it is still wired. It's still a tethered VR headset, which feels like it's a big missed opportunity. A big missed opportunity there to go wireless, since, you know, you look at PlayStation, all their you know, controllers and stuff have been wireless for years, and now VR is considered, you know, like it's not even good unless it's wireless, is kind of the current thought process on VR. All right, so now from a exam perspective, difference between Quest and Quest 2, maybe not anything from that, but certainly the idea of the inside out tracking mechanisms for VR tracking. I could see something with inside out or outside in tracking finding its way onto the exam in terms of how does each one work? What are the trade-offs? Something like that. Okay, so questions about any of those things, or questions about the exam?
So you said it's gonna be live. You said it's gonna be live Thursday.
Yeah, I'll probably actually put it up Wednesday night is my guess.
Okay.
But
You do it
but it'll definitely be up by 8 a.m. on Thursday before class starts. So on Thursday, I will get onto Zoom just like I did this morning. But you know, we won't have a normal class. The expectation would be if you want to take the exam with me sitting here, able to ask me questions or something like that, you certainly can. I'll be available. I'll log on to Zoom, all that stuff. But you don't have to. You can take the exam anytime you want, as long as you do it in a single sitting, and I have it by midnight on Sunday. And then make sure you look at your schedules for next week, because the next course will be starting. I don't remember what day my class meets. Is it 5:49? What class do I teach next week?
Is it the same time? Because
It might be. It might be the same time. Let me see.
I'm pretty sure it's 8 a.m.
Yeah, but is it the same day? That's my bigger question. Let's see. Tuesday. Oh, it looks like 5:60 RESTful APIs, right?
I believe so.
Yep. And it looks like it's Tuesday, Thursday mornings.
Yep.
Yep. So if you're not already enrolled, make sure you get enrolled in that class. That is only for the software engineering majors, though. If you are not software engineering, then you're probably there's another class being offered. I don't know which class. Maybe it's one of might be advanced networking, or it might be one of the system design classes. I'm not positive. But in any case, make sure you remember classes start next week for the next 8-week session. All right, questions, comments, concerns, bribes. All right, I will see some of you on Thursday if you want to take the exam during class. Otherwise, I'll see hopefully many of you next Tuesday for the RESTful API, and hopefully I have my cough figured out by then. All right, have a good one.
Thank you.
You as well.